So this will be somehow half technical, half esoteric, part strange, rambling around this idea of shift registers, or which I like to call shiftless registers, which is kind of a technical kind of joke. So what I'm going to talk about today is the shift register, which some of you may know, which is a digital device, circuit or conceit, which links technical and media histories with the esoteric and the geological. So the shift register, which is kind of, let's say, an obsession of mine, which also kind of comes out in performances, comes out in different projects, is somehow a way of thinking about memory and decay. So first of all, what I'd like you to imagine is what this shift register is, which you can see on some of these images here, which the kind of classical description is as follows. So a shift register is a type of digital circuit using a cascade of flip-flops. So these are basically, as the name implies, like a flip between a 0 and a 1, or a 1 and a 0, which is kind of holding its state. And this cascade within this sequence of cells, which we can see on some of the slides, the output of one of these flip-flops is connected to the next one. So basically the data is like the 1 or 0 is shifted along and can also be shifted back to the beginning. So this is a form of memory. So data can like cycle through the shift register depending on a clock signal which is given to the shift register, which is then shifting along one by one, going round and round. So what is kind of interesting here is that this was a very early form of memory. So if we have something which is, let's say, decaying, so some memory which is not holding its state over a length of time, but is actually rotting or disintegrating. So for example, an impulse of sound or light which is fading out, if we kind of pass it round and round, it's being kind of refreshed at each instance. So this was used in delay line memory systems that kind of somehow equivalent to the shift register, or would make use of the shift register. So what I'm kind of interested in is the key characteristics are the movement of well-defined data, as in we need a 1 or a 0. As Thomas was also pointing out, we can't have something which is fuzzy. It needs to be defined at that instance of passing on as either a 1 or a 0. So we have this well-defined data, and then this is being passed on from cell to cell and returning. So this is a form of memory which is acting against decay or disintegration or leakage, or so the kind of the characteristics are that it's well-defined, it's contained, and that it's passed on from one cell to the next. So I'd like you to imagine that, to hold that in your minds, the sequence of cells circling with data being passed along. And as I mentioned earlier, this was kind of the principle of the delay line. So we have the acoustic delay line, the light delay line, in which like light is more or less being passed towards a detection of light, and before that light signal has decayed, it's being fed back through the system. And then we have the famous gin-based delay line from Alan Turing, the computational pioneer. So using liquid, well, the drink of gin as a acoustic kind of carrier for these delays. So when I first kind of encountered this thing called the shift register and first became obsessed with this, somehow this was linked to the idea of the Ouroboros, the serpent eating its own tail, from ancient Egyptian mythology going into medieval alchemy, which is another kind of connection which I like to make between the digital and this kind of, let's say, more esoteric realm, or something which was very much dealing with materiality but in quite an interesting way. So I'm going to read a quotation from the Electronics Design Network website, which goes as follows. In the rarefied realm of digital designers, an equivalent to the Ouroboros is the linear feedback shift register, also known as LFSR, in which the output from a standard shift register is manipulated and fed back to its input so as to cause the function to endlessly cycle through a sequence of patterns. Much like the Ouroboros, LFSRs keep on rearing their heads again and again, because however much you know, there are always more tricks to learn. The great psychoanalyst Carl Jung speculated that the Ouroboros could be part of the collective consciousness. So had he dabbled in electronics, he may well have considered LFSRs to form part of the digital consciousness. Hold on to that couch, Carl, I'm on my way. So this was kind of somehow confirming this connection, which I'd already made myself, between the Ouroboros and something which is kind of otherwise confined to this electronics or digital domain. So very briefly, like the first shift register was implemented within the Mark II Colossus, which was a code-breaking machine built towards the end of the Second World War. This was a 6-stage device built of vacuum tubes and thyrotrons, and a shift register was also used in the IAS machine built by John von Neumann and others at the Institute for Advanced Study in the late 1940s. So it was used within this Colossus code-breaking machine as a way of basically like being able to process data in parallel. This is somehow like an other kind of useful characteristic of the shift register, is that things are kind of shifted in to this kind of, how to say, like array of cells, and then they can be shifted out all in one kind of chunk. So it's a way of going from, let's say, a kind of very serial idea of time to a kind of more or less like a parallel idea of time. So they write about this processor. 5 separate processors presented little difficulty. A photoelectric reader, to supply them with data, would have to read 6 lines of tape simultaneously and would be very difficult to construct. 6 lines were needed so that 2 consecutive but different lines could be presented to each of the 5 processors. This difficulty was solved by shift registers invented for the purpose. And then it carries on like this. There's also a kind of a long history of the kind of musical or artistic use of shift registers, particularly within synthesizer technology, maybe since 60s or 1970s, as a bridge between, on the one hand, like random noise, and on the other hand, recurring music-like patterns. So these were instruments like the Triadics Muse, which we can see on one of the slides at one point, which I think had 32 stages of shift registers, as well as different clocks and, let's say, different kind of time bases that would feed into this shift register. The Benjalin, which is more recent, and also more recently, like the use of shift registers within kind of digital filter structures, because there are certain parallels. So somehow the shift registers became somewhat of an obsession for me, to the extent that I was part of a 2 or 3 year project at the Critical Media Lab in Basel, which some of the slides also relate to, which was called Shift Register. And part of this lecture in some ways is about explaining how I came to that title and how that kind of perhaps connects to wider concerns, which are also kind of mirrored in some of these images. So the idea of this project, or the reason why it was, or somehow I can't really explain the reason, but anyway, the nature of this project was to, let's say, render experiential the questionable markers of the Anthropocene. So the idea was to kind of like shift those registrations, for example, like radioactive isotopes within all living things, to kind of shift that registration out of a purely scientific domain into something which was experiential. So to kind of move things out of their kind of, let's say, constrained containers in some sense. So the Shift Register project was investigating and rendering legible the material evidence of human activities on the Earth, registering these not as indicators of human achievement, but as ambiguous negotiations and signposts of planetary exhaustion. The project undertook fieldwork and research rerouted from the natural and physical sciences as the means to bear witness to these sites of human impact. Also, another part of what I'm kind of interested in is the idea of shifting the site of execution, which is maybe a longer topic or area to explore. But what I'll do is read a quotation from an essay called "What is Executing Here?" by Eric Snodgrass, which was about this idea of shifting the site of execution, so shifting where exactly this thing which is called software takes place. Like, we can ask this, I don't know, at first it seems like a very simple question, that obviously this thing called software takes place within technical objects like this, but it's not really such an easy question to answer, because it's also taking place within human lives, within financial structures which are affected by algorithmic activities, within geological structures which are also affected by the same geological activities, and so on. So he writes, which is in connection to this question of this kind of fault line within something which is kind of black boxed or contained, like these technical objects, for Howse, which is me. One method or exploit for triggering a reacquainting of the fault lines of such a question, this question of black boxing and where the site of execution takes place, is the act of shifting the site of an executable process from its typical or stabilized domain to a less typical or stable one. To this end, he carries out a range of experiments that in one way or another attempt to shift computational sites of execution into new material data outside the particular confines of a trusted and identifiable process. So one very quick example of this, which was an older work which I made, was to take the instructions which were executed by the Firefox web browser, one by one, and to interpret those as the movements of a needle on my own skin. So if the instruction was like to translate them into numbers, a certain number, it would be a certain depth of the needle going to the skin, but I never actually completed the process because the whole thing took 12 hours and was already painful after 10 minutes. But it was an example of like taking programming codes and just putting them somewhere else, like where they don't really belong in another realm, but somehow shifting them. So I move on to another way of looking, what I'm driving at is another way of looking at the shift register as something which is geological in a sense. It has to do with stratification. There was talk earlier about erosion, which is also to do with this kind of revealing of strata, let's say. But we can kind of look at stratification of geological layers as somehow very akin to a shift register. Like the layers are kind of put on top and descend, put on top. I mean, there's maybe some kind of recirculation, but in very specific cases. So we can think, like one image which comes to mind, which occasionally might come up, is a geological core sample. So where kind of like a whole chunk of stratified matter is extracted and examined. And during the shift register project, I was working a lot with peat bogs because somehow they also have a very special connection to decay. And we would pull out I think 3 or 4 meter long peat samples, and it was just somehow exciting to see like the top level, which was more or less like living matter, like mosses and grasses, very wet, and then going down to this very like putrid, denser, dark matter towards the bottom of the sample. So this is kind of one way of looking at shift registers. This is relating to the geological, but in a sense, what's kind of interesting is that these shift registers are working in algorithmic time. We have this kind of clock. It's very discrete. It's not a kind of continuous process. So it's also somehow like particulate. So at the same time, the shift register is also, despite that algorithmic time, somehow organic in the sense of like when we kind of work back to this idea of like that it was used to kind of memorize or to store decaying values, there is this very kind of clear relationship to decay within the shift register, that it's always like somehow passing on the last living, I mean, this is a bit dramatic, but just for the sake of the imaginary, like passing on the last living moment to the next cell where it's somehow like resurrected. So we can also see this as something, maybe Catholic shift registers or something like this. So it's like reborn in a new identity. And also that's, again, the connection to go back to the Ouroboros is like that this is also about this cycle of rebirth. Not that I'm religious, but, anyway. At the same time in this, so I was like started to think through this like shift register geological connection, and then I was reminded of Samuel Beckett, which I kind of was reading a lot at the time, and the novel Molloy, and there's this kind of famous scene with sucking stones or pebbles. I'm just thinking, how am I doing for time, actually? It's good? Really? Okay. Yeah, I went over. So I don't read out the famous sucking stones thing, but more or less it's like, it starts off, basically it's this problem of like how to, so he's sucking these stones at the beach, and it's really about how to kind of make sure that he has like, I think 16 stones in various pockets, and he doesn't want to suck the same stone again, so it's a method of like passing these stones around between pockets, but then there's always this dilemma of like, how does he know, no matter what the scheme, whether he's like passing these stones on. So I thought, okay, this is another shift register with these sucking stones. And then after a very quick search session, I found out that there is actually a digital code named after Samuel Beckett, which is the Beckett-Gray code, which was about somehow solving those kind of problems within the digital domain. So I'm going to jump to the end, more or less, which is about, so the kind of, to jump forward, what I kind of arrived at and the kind of conclusion of this, there was a word for this, towards decaying mortal particulate logics was the conclusion, I think, or shift registers as a methodology for becoming geological. So the kind of, where I arrived was at this basically thinking about the shift register as a model for what could be the potentially becoming geological of humankind, which I work on in another project called Tiny Mining, which is about the extraction of minerals from within one's own body as a way of becoming more embedded within geological cycles. So the conclusion is more or less that we can think of the stage we're at in terms of the anthropocene as something which is akin to a shift register, and that we're inhaling and ingesting our own geological indicators. So the signs that we place on the planet of our own, let's say, occupation, are actually becoming, or in this kind of return, like being integrated into our own bodies. So we're kind of like not only placing these markers on the Earth, which are geological in terms of radioactive isotopes or other indicators of the Anthropocene, but we're also being incorporated by those things. So it's somehow a cycle which I'm kind of quite interested in. There was a big chunk missing. Thank you.
Brilliant. Thank you very much, Martin. So, yeah, I think we have 5 more minutes to go. So are there any questions from the audience, maybe? And if not, I wanted to ask you, Till. There was one. Yes, please.
Okay, sorry. Now, do you also see a parallel between shift registers and maybe what happens between parents and children, or how information is passed from generation to generation? Is this kind of a shift register process? Cultural, maybe?
So, to be honest, I'm not so sure that I would, because it's kind of like, also I kind of like, what I'm interested in doing is kind of like stretch, I mean also like, not to pile too much on top of each other, but like shifting the shift register itself. So what I'm, like a lot of my work is really about like taking, let's say, the constraints of digital systems, or that there cannot be any leakage between, let's say, these cells, like they have to have a very firm identity, but which is like one aspect of the shift register and of the digital, let's say, is that it cannot leak out across its borders, let's say. So I think the problem is, like, if you take this kind of generational metaphor, that would imply that there is no, like, room for change or transformation or difference, or, you see what I mean? That, like, what I'm interested in is, like, the shift register is not really a good model, but it's a good model when it becomes kind of, like, slightly, let's say, played with or twisted or shifted. It's not really a good model anyway.
But it's a nice model to show complexity in a very small structure, right?
Yeah.
And
yeah.
What I was wondering, because you talked about LFSRs as well, and they were used a lot for indexing, so to count, basically. But the counting of LFSRs are kind of interesting because you're not counting from 0 to 1,000 in that order, but you count in a kind of random order. But you move through everything, so this is the stone-sucking thing in a way, right? So I was wondering if there is some kind of relation to your ideas about getting this into this anthropocenic model there, like the counting aspect of it.
Yeah, that's something I haven't really thought of. And the other thing I guess that we should mention was that, so the linear feedback shift register is more or less when you, I don't know whether I can find that, but that's not it. But anyway, so it's basically where you kind of have, like, let's say you have 16 cells and you feed back the first and the third to the beginning rather than just feeding back the last to the beginning, let's say. Not the first, doesn't make sense. But so there are certain kind of tables for this feedback, and if you have a long enough shift register, it will generate basically random numbers which do not repeat depending on the length. Like, so if you have 64 of these cells, you could have, like, I don't know, millions of unique random numbers, I guess. But I didn't know so much about the counting aspect. Yeah. But I was kind of, I don't know, also with this whole, like, Beckett thing, that was something I started to investigate, which is really about, like, so they kind of, can I carry on for 1 minute with the Beckett thing? So what was kind of interesting was, so he wrote this play called Quad, and he had, like, basically the instructions were that all of the actors had to appear on the stage in all of their configurations, and they would come on one and one would leave, and the one who was on longest would leave, like, the first out of that, if that makes some kind of sense. So anyway, there was a huge, or not, but I started looking at so this became a problem in computer science, and there was something like, I was reading this paper recently where it would take, like, months of powerful computer time to just look at how to make that happen for 6 actors or 7 actors, which is kind of, because he never solved it for 4, and it's unsolvable for 4 actors. There is no solution, but it's kind of somehow just that, I don't know.
So it is like tiny structures and tiny instructions that create, like, this immense complexity.
And then just thinking about the materiality of 4 months of computation just to figure out how to get 6 actors on and off the stage is kind of interesting. So it's really that kind of interplay, I guess.
Okay,
Thank you.
Thank you.